Robert Boyle, Boyle's law, pressure and volume related somehow. Demonstration I showed you all is the marshmallow one in the syringe. So hopefully this will make sense in terms of what we're trying to say. So the Boyle's law is P1 times V1 equals P2 times V2. So pressure 1 times volume 1 equals pressure 2 times volume 2. Volume of gas and pressure of gas are both inversely varied or inversely related. Comparing that to Charles's law, that's directly related. So we said that in Charles's law, if they're directly related, that means one goes up, the other goes up. One goes down, the other goes down. So with Boyle's law, if pressure goes up, volume goes down. If volume goes down, pressure goes up, etc. A helium balloon has a volume of 45.2 liters at a pressure of 745 millimeters of mercury. What would its volume be after floating high in the air where the pressure is 640 millimeters of mercury? Volume 1. So you'll notice that these are related. The volume is at a pressure, so that means that this has to be pressure 1. What would its volume be after floating high enough to a different pressure? So P1 times V1 equals P2 times V2. I am trying to solve for V2. So P1 V1 over P2 equals V2. As long as your units are consistent in your problem, you don't need to convert. However, if I gave you one particular unit of pressure and a different one, you have to convert it to the same at least. So pressure 1, 745 millimeters of mercury times 45.2 liters divided by 640 millimeters of mercury. Those units cancel out. I am trying to find V2. So 745 times 45.2 divided by 640. My volume is 52.6156, blah, blah, blah. So let's keep it consistent with that. So it's 52.6 liters. So the pressure went down, the volume increased in this example. What pressure is needed to compress 10 liters of air at 0.985 atmospheres to 3.75 liters? Moles and temperature are constant, so we ignore that. Those things do not influence what we're talking about right now. That's what I mean. So what pressure is needed? So some pressure to compress 10 liters of air at 0.985 atmospheres. So these are grouped together. So the liters at particular atmospheres. So this is volume, this is pressure. So these are grouped together somehow to a different volume down here. So these have to be the same. So this could be P1 V1 and this one can be P2 V2. So I'm trying to find P2. Divide both sides by V2, I'm sorry. So P1 is 0.985 atmospheres times 10 liters divided by 3.75 liters. Liters cancel out. I am trying to find P2. Atmospheres is going to be my unit, and that's fine. 0.985 times 10 divided by 3.75. I end up with 2.626666. So looks like we have 3 sig figs, so I'll go with that. 2.63 atmospheres. Box it in. Volume decreases, pressure increases. Real life application of Boyle's law. So scuba diving. Some of y'all have done it before, I imagine, or have family members who do it. So this is a real-life application of Boyle's law. Pressure increase, volume decrease, etc. So there are different components to diving, and it's very important to kind of follow the rules that they give you when you get lessons and be certified, etc. So you have to descend and ascend properly. So as a diver descends, the pressure increases. Pressure increases. Air in his scuba equipment and body occupy a smaller volume, so they compress. So pressure increases, volume decreases. Air compresses in a diver's ears, and therefore you need to equalize the pressure somehow to avoid something called ear barotrauma. So barotrauma. So baro is pressure. Trauma is injury. So obviously, so this is injury related to changes in pressure in the ear. That's what it stands. That's exactly what it means. As the diver ascends back, goes back up, water pressure decreases. That means volume has to increase as well. It's going to occupy a bigger area. And that's why you need to release excess air from a BCD, right here, buoyancy compensator device, as a diver ascends correctly. See? If you don't do that correctly, something happens. If you don't release the air from this, what you're going to do is you're going to have too much air in the lungs, in the body, somewhere. And that leads to a specific medical condition we're going to talk about in a minute. More rules of scuba diving, etc. Do not hold your breath underwater, because if you do, if you ascend too quickly, the air trapped in the lungs will expand. So again, pressure and volume all related somehow. And with this expansion, this can lead to pulmonary barotrauma. So pulmonary is lungs, barotrauma again, so trauma or injury related to changes in air pressure in the lungs. You're supposed to ascend slowly. So in a scuba tank, there is nitrogen gas. While a person dives, their body is absorbing nitrogen gas. However, if you do not ascend slowly enough, that volume of gas, because the pressure is decreasing, the volume of gas increases too quickly. And what happens is you can form tiny bubbles of nitrogen in the blood and tissues and cause something called decompression sickness. And this is the medical thing we're going to talk about. So decompression sickness, it is known as the bends, the chokes, and the staggers. So these names actually come from the different places that the nitrogen bubbles can expand in. So decompression sickness is caused by nitrogen bubbles forming in the bloodstream and the tissue. These bubbles appear if you move from deep water towards the surface too quickly. If you do not ascend properly, these bubbles appear in the blood because the pressure is decreasing, so the volume of the bubbles, the gas, increases. So the pressure decreases as you ascend back up, therefore the volume of the gases will increase. So this is still Boyle's law. Watch this clip. I put it on Google Classroom for Rescue 911. It was a TV show back in the 80s and 90s. And this one is related to somebody getting decompression sickness. So there are a couple of symptoms for you to think of in terms of decompression sickness. Some may get headaches or vertigo, being tired or fatigued. Some may get a rash or pain in the joints, tingling in the arms. Some people have difficulty breathing. So the thing is that these different symptoms occur because of where the nitrogen bubbles are expanding. So headache would be blood vessels in the brain. Tired or fatigued, that could be in the brain as well. In the skin because of rash. If the blood vessels, if the bubbles expand in the joints, you can get joint pain. Breathing difficulty could be if the volume of gas expands in the lungs. Stomach pain, chest pain, if the nitrogen bubbles expand in those different areas. So there was a house episode a while back. I think it was decompression sickness, where this person went diving and then they took a plane back home. So what happened was that the pressure changed dramatically from from the sea to the ground, then it went into the air. So remember that pressure decreases dramatically from the sea to the air, therefore the volume increases as well. So they cause all the symptoms that that person felt. So if you have any questions, let me know. This is the end of the lecture. This first homework is going to have Charles' Law and Boyle's Law questions. Alrighty. Hope you're all doing well. Take care.